Hey, hi everyone. Good to see y'all. I want you to open up Google Classroom. I want you to follow along with me for just a quick second. Here's our plan for the day. I want to take a minute and kind of practice a couple things because tomorrow's going to be a little bit weird. So my goal is to kind of go through this. I mean, we still have about 30 minutes tomorrow, but I don't want to base our whole week on whether or not that goes off as planned. Okay, so we are going to have our first test on Wednesday, and I basically compiled that test yesterday. Is it yesterday or the day before? Yeah, and so let me explain what your quote unquote review sheet will be, and you can follow this with me. So basically what I did is I went through all the multiple choice questions, and I really tried to get a good sampling of what, like I want to see, are you getting these concepts? Okay. Are they sticking with you? I did not write these questions. Okay. I've written plenty of test questions. In fact, I think I told you I got hired by the textbook company to write the sapling questions for their online testing program. We did not, which is kind of silly, but we did not subscribe to that for you because we still are on the second edition of the book. So I think this is our last year for that edition, and then next year we will go to the third edition. But I really debated on what to do for this test. AP Classroom has done an incredible job of putting together resources to make it worth your while, I believe. So we're going to try this first test, and it will be online using AP Classroom, and we're going to go for it. So basically what I did is I went through all of the standards, okay, or the different units, okay, and picked up a bunch of them. It ended up being like 75 questions. And then I went from those 75 questions and I divvied up the ones where I was like, these are the ones I really want, and the ones I feel like are important. These are actual AP test questions from past tests, okay? I want our tests to be not just like, for a grade in this class, but for practice in the ultimate thing. And I wrote this down because I didn't want to forget it. Okay, but I definitely I did this more for me maybe than you. Okay, so and you can read this. I won't read it word for word, but I really struggled, with teaching this as an AP class. When I started teaching here, 1994, there were two biology classes. We called them Bio 1 and Bio 2. And Bio 2 was kind of like an AP Bio, but not really. Okay. And so I can't remember. I think I was mostly the only Bio 1 teacher. I think Oris Hippensteel taught like a couple like low level, we called it something else, like intro to bio, something like that. Then in 1996, I had a group of like 5 students who were like, we want a class as a senior. If we took bio 2 as a junior, we want a class as seniors, yeah, and we want to do environmental science. So I conned the principal into it, and he went for it, and he was like, let's do it. And so that was the first ever quote unquote bio 3 class, and it was really fun developing that curriculum and whatnot. And I always kind of resisted, like, I was like, I don't want AP because I don't want to teach to the test, right? And I really kind of like felt that way for a long time until I, started to get more into like what the College Board was doing. And trust me, I don't love everything the College Board does. In fact, I get angry at some of the stuff they do. But I think what's really important is that this class will hopefully, by the time you're senior, it's like be a class you're like, okay, I actually had to like think about that stuff. And I know some of you are like, screw that. I don't want to think about stuff, right? I don't want to have to think. I want to just regurgitate that. Okay. Why do so many people get like A pluses on my anatomy class in the fall? Okay. I mean, it's not because of me. I think it's because there's either one answer and you know it or you don't. This is the humerus. If you don't know that's the humerus, there's no other question about that, right? That's not how the AP classes do it, right? They're not about just like memorizing facts and getting those facts out. And those of you who've taken those tests before, right, are probably like, oh man, what the hell, like you still have to know like what ATP is. You still have to know certain things, but they're going to ask you like bigger picture items, right? You know what I mean? So this first test is going to be going to be weird, and I may curve it depending on how it goes. Okay, but I won't do it after this. I want this first test. I want you to study, but I also want to really talk about it afterwards. Okay, you all with me on this? You all with me on this? Okay, cool. So anyways, that's kind of what I wrote down. I ended with, this always drives me crazy. And I get it happens, okay? But please try not to be this person that shows up on Wednesday and are like, oh wait, we have a test today, right? We've all been there, right? And I know I hear that a lot, like, oh crap, we have a test today. This should not be like a class you're like, oh yeah, I totally forgot we have a test, right? Okay, you got to be thinking about it and like looking for some of these things. So I'm going to help you. I'm going to give you some ideas. So the nitrogen cycle is going to be huge. Okay, right? And so 3 or maybe 4 questions in that. Okay, know this. Okay, you're like, oh crap, do I have to memorize all of these things? Do you want to know the ones that I really want you to know? You want to put stars by it? Okay, I'll show you. I'm going to mute this real quick. So if you want to put stars by this, and I also gave you on the Google Drive, I gave you, hold on, I have to find this real quick. I gave you a document of the Kahoot stuff. So you can ask yourself, those were directly off of this. Okay, hold on, let me go to the top here. I need you to know. Sorry, scrolling. 20 questions. Know these. So NH4 plus, that's ammonium, into molecular nitrogen. NO3 is the nitrate. Nitrate. NO3. NH3, ammonia. N2. I already got that one, right? So just know those on that one. That doesn't mean that the other ones like nitrite to nitrate, okay, that kind of stuff, but you're going to have to look at that picture and try to fit it into kind of a bigger scheme of things, okay? Right, so definitely know those pieces. All right, let me show you this thing real quickly too, just as a reference. Remember this thing. Can anybody remember what the name of this curve is? Keeling curve. Good memory. Keeling. Named after the dude that started studying this stuff. And this is measuring CO2 concentration, right? Okay, but remember, we've got this up and down thing, right? Why does it go up and down like that? Because that's the way it is. I know it's a maple tree because of the way it is. Do you guys know that skit? Yeah. Come on, man. Okay, notice like when it's happening. Okay, it looks like half of the year it goes up and half of the year it goes down and half the year it goes. It's the trees, right? Right. What's happening with the trees? The leaves die. What's the name of that process with it stops?
Condensation.
No. I love how confident you are there, but absolutely not even close. Okay? Photosynthesis, right? Okay, photosynthesis taking that carbon from the atmosphere, right, and converting it to what's ultimately, we want oxygen, okay, but what's the food that glucose, right? The food is glucose. Why do we need glucose? Why do we eat food?
Open doors.
Open doors.
ATP,
Okay,
baby.
that's ATP, baby, right? What's ATP stand for? Adenosine triphosphate. Where does phosphate come from? Phosphorus. Where does rocks, right? And phosphorus is the only one that doesn't have what kind of cycle? Atmospheric, right? Okay. It's just literally from the rocks. Okay. Now listen. Okay. Remember with this one too, this is a rock. Cool. I release this, right? Okay. Or I burn this and I do get two bad things that are going up in the atmosphere. One is carbon, right? With carbon dioxide. What's the other one? Sulfur, right? So the sulfur cycle, even though it is in rocks, even though the carbon is in rocks, right? It does have that atmospheric, component to it, right? You all with me on that one? Everybody get that? Everybody got that? Okay, cool. All right. Now let me see. What else did I want to show you real quickly? Yeah. Sorry. Yeah, just a second. I don't know. Look through the stuff. Let me talk about this for a second. Right? Okay. How about this? Okay. Primary producer. What's a producer? It puts out. It definitely does put out. It's what? Autotroph, right? Okay, we'll give you an example of a producer. A plant, right? Okay. Right. Okay, primary consumer. What does the primary consumer eat? It eats plants, right? Now let me ask you this question. This is a tough one. This is a real thinker. Does a primary consumer have to be a small thing? Name a big primary consumer. Elephant. Okay, cows. Yeah, sure. They all eat just grass. Okay, those are good examples too. All right, fantastic. I want to make sure that you knew that. All right. pH, what are my numbers with pH? Okay, 0 to 14, right? What's the bottom part? Acidic, what's the top part? White noise. What, white noise? White girls. Basic, oh, yeah. Yeah, sorry. And then what are my ions when I'm going up? Hydroxide, sorry. Okay, hydroxide, what are those letters? OH negative, right? And then what are my ones going down? Hydrogen, right? H plus. Okay, yeah. All right, now listen. Okay, so the FRQ is going to be about acidity in the ocean, right? Now, is the ocean acidic or basic? It's basic, right? But it's becoming more acidic. Why? There's increase in hydrogen ions, but what's happening? The CO2, because the ocean is a giant carbon sink. Okay, in your notes, and I went ahead and included the chapter 2 notes. Remember I said we're not having a chapter 2 test. Okay, yeah. Not having a chapter 2 test, but I said we're going to talk about energy levels. Okay, and then we're also going to talk about pH. So remember this rule of 10 here, right? Okay, so I just take away 0, right? Because I'm only sending up 10% here. from before. But let me read this thing again, and this is also in your notes. So this is in your chapter 2 notes that I gave on that Google Classroom. Okay, so once again, when a molecule of carbon dioxide enters the ocean, that's CO2, it finds itself attracted to water, right? So CO2 and water, carbon dioxide and water sitting in it. All right, these two molecular parents spawn, I like his word choice there, carbonic acid, that's H2CO3, which then releases one hydrogen ion, leaving a molecule bicarbonate, that's HCO3 negative. The concentration of those hydrogen ions is measured as pH. The more hydrogen ions, the more acidic, but the lower the pH, because increasing hydrogen ions push seawater pH towards the acid end of the scale. This is called ocean acidification. So CO2 and water, they like each other. They form carbonic acid. That's a lot like nitric acid, right? Okay, but that's unstable. H takes off. Hydrogen's always taken off. Oxygen's always taken off. When we talk about ozone, it's like chlorine and ozone get together, and the O2 is like, peace, I'm out. Okay, it's weird. Okay, so that hydrogen takes off, and we get HCO3, that's bicarbonate, right? So the problem is that hydrogen ions easily bond with the carbonate ions. Using up carbonate ions deprives animals like hard corals and snails and plankton for using that building material, right? Okay, so that's, please know that stuff about pH in the oceans. Okay, and again, you can always watch this video later, okay, if you need some stuff. But I've given you some pretty major hints there for stuff on your test. Okay, what's the name of the thing in the roots, by the way? What's that thing called? Rhizobium, right? Okay, good. Energy cannot be created or destroyed. What do we call that? Yeah, that's the first law. Okay, it tends to go towards entropy. So in this case, okay, this is like the second law of thermodynamics. Sorry, I keep pointing to this, Mags, over there, that little thing. So hopefully you got that. Producers, consumers, consumers, consumers. All right. What questions do you have? 20 multiple choice. We'll talk about it afterwards. 1 FRQ Wednesday. Okay. Oh, there's no extra time on the AP test in real life. So there's no extra time on this test. Every test I make is doable in the short amount of time we have here. Okay. I think about it a lot. So let's practice. Okay. All right. Let's open up. I want you to go real quickly to your assignment. So go to classwork and go to chapter 3 questions, and then go to open up your stuff. I don't know if you looked at my comments at all. Okay, but I want to hit a couple things in this just to make sure. Has anybody ever been to Haiti or the Dominican Republic? I know that for a while it was like a thing. Yeah, go ahead and just pull up your questions. That'd be awesome. Thing that like I know like Morgan Jimenez and like who else was going there for a while? Reagan, Bellinger. I don't know. There's a bunch of people going to Haiti for a while, right? So Haiti had a big thing going on several years ago. What happened in Haiti? Really devastated there. Yeah, huge earthquake, right? Yeah, and people are still going to Haiti to get aid, right? But if you look at the picture on the beginning of chapter 3, the Dominican Republic is right next to Haiti, right? It's insane to think about that. If you're interested in this sort of stuff and want to read more, I have this book called The World Until Yesterday by Jared Diamond. I'm a huge Jared Diamond fan. He's the one, and don't like some of you might be like, oh, Jared Diamond. Some of you might know Jared Diamond because of a class at Manchester that maybe you took as sophomores, or maybe it wasn't here yet. And well, now they have to read, not this book, but they had to read Guns, Germs, and Steel. Anybody know that book? Yeah. Human Geo. You guys take Human Geo? Okay. Did you have to read Guns, Germs, and Steel? I like the dude. Okay, you're probably like, I can't believe I had to read that book. This one's really interesting, and this book, the whole point of the book is that Jared Diamond said, if you want to collapse a society like in Haiti or in, let's say, Easter Island, or these places that had like these huge populations, and then everyone died or things went bad, it was because of one reason, and he ties it together with all these other places, and that is that they don't take care of the resources. Okay, they cut down all their trees, and boom, instant poverty. Okay, and this is a perfect example because in this one island, you got Haiti on one side, you got the DR, the Dominican Republic, on the other. Now, we're not talking like the DR is like the richest country on the planet, but when you have all the same environment, right? And one side is extreme poverty and the other is like not too shabby, right? What's the difference? And you can look at that picture and see that boom, there's a line right down the middle. Haiti, no trees. Dominican Republic, they took care of their trees, right? So they started talking about that, and I liked your responses to that and deforestation. But then we started looking at ecosystems, and hopefully all of you know this. I will tell you that the GPP and NPP, remember we drew that picture, okay? There's an arrow coming off of your notes, a giant arrow, 99%, okay, is not used for photosynthesis, right? Okay, if we look at that other side, we're only using 1% of that, and only 40% of that 1% is going to be used, okay, which is just nuts. So make sure you know those. I love looking at your nitrogen and your phosphorus. Some of you didn't answer all those. The number one way to miss points is if you just don't answer the question. So if you did not get a 30 out of 30 on this, it's because you forgot a couple things. And I like to ask more than one question on a lot of these things, right? Oh, by the way, I did appreciate this. I won't pull up Justice's response, but I did appreciate that, Justice. I didn't try to trick you there, okay? But a lot of you, well, he wrote a little smart aleck remark. You tried to do, what did you say exactly? That was good. Anyway, a producer and an autotroph, same thing, right? What? Just trying to make you think. All right. Let's look down, and we now know that your watershed picture is a little bit different than the one that you picked. Look at your picture real quickly, and if you look at your picture, it probably does not look like my picture, which was this one that we determined on Friday. So this is the eel. You may have only picked the middle eel, okay, which is like this chunk right here, okay? And that's okay. I don't think anybody got like the whole nice picture like this, right? You all know like this is the Eel River watershed now, right? What's that? You did find a good one? Let me see. I can't remember. There's one. That's pretty good. That still goes down though. That encompasses way more. So this is the larger brush rather than just the smaller. What are you doing? Are you you're looking at your stats?
Not my stats, my office.
Okay, there you go. All right. So here's what I want you to do. I want you to go ahead and I want you to pull up your article from your thing. Some of this stuff you're like, hey, we're not even going to be testing on this stuff. It will come back. Watersheds will come back. Okay, I don't know why I didn't ask you a live question on watersheds or about trophic cascades, but I promise you, you will see that again. I actually debated. I was like, man, should I make this test worth like 30 or like 30 questions? I don't know. We're just going to stick with it like this. But let's talk about trophic cascades for a second. And if you can, actually pull up your article. So I pulled up this one because I thought this one was really good. Species-specific autogenetic diet shifts attenuate trophic cascades and lengthen food chains in exploited ecosystems. That's heavy. That's a heavy one. Okay. The ones that people picked that were classic, Okay, and I wrote a little note on there for you. If you picked one about Yellowstone, or if you picked one about wolves, it was huge, right? That one is the key. I mean, like the standard. If you're into this sort of stuff, I also have a book called The Wolf's Tooth. This is all about keystone predators and wolves, and how reintroducing the wolves back into Yellowstone completely changed that ecosystem. Okay, so trophic cascades, what does that mean? That means if I introduce maybe a secondary consumer, okay, it's going to change the complete makeup of this trophic pyramid. Y'all with me on this? I forget who had this one from Waitrose. Whose was this? This was a good one. Nobody? You don't want to admit it?
Nobody, Jade.
Somebody had it in here because I wouldn't have found it otherwise. All right. This is the species. That was you? Yeah. It was good. I liked it because it was pretty current too. All right. So remember, the idea here is that you've got your abstract. Don't forget to copy and paste your abstract in there. A few of you did forget to do that. And notice in your comments, there should be a little note that says, "Ooh, I really like this one," or "This is a good one." Okay, I mean, not on everybody's because I didn't love everyone's. I might have. This is a classic example. Okay, if I made a note on your homework, that means we might talk about it and you might be asked to explain a little bit more. Okay, you're like, "Oh, I don't understand." Okay, remember the abstract is like the sum of all the paper. Okay, it's not the trailer, it's the shebang. The introduction, that's kind of a trailer. Like, here's why we did this, here's what we hope to study. Okay, the results, that's what we got. Or sorry, the methods, this is how we did it. The results, this is what we got. The discussion. You're not getting into that whole paper. You're just doing the abstract. But in these first few sentences, that's the intro. The next few sentences, that's the methods. The next few sentences, here's what we got. And then the discussion is the last few sentences. Okay? Does everybody understand that? I know this is not the most exciting period today. I apologize. Everybody's looking at me like, "Kill me. I hate this. I'm bored." Okay, sorry. All right. Any questions on this? What time is this class? I don't remember. 22. All right. Let's watch one little thing real quick and then we'll quit. If my internet works.
Guys, at the funeral, I have one request, and that's he chose me. Okay? That's all I ask. I know that I'd be crying on some simple shit like, be happy.
All right. Here we go.
And I want tamales, right?
You want what?
Tamales.
Oh, that sounds great.
Yes, those are my requests.
Those are your requests. Those are good requests.
I feel like they're very doable. Not too demanding.
All right. Stick with me for. Oh. You'd fight a wolf.
I would cuddle a wolf.
Did you know there's a place called Wolf Park? It's near on the way from here to West Lafayette, and you can go and howl with the wolves. You have been there?
Yeah.
What was your experience? Did you like it? Was
Yes,
it weird?
they did like a tour.
Uh-huh.
I feel like they get lonely.
One of the most exciting scientific findings of the past half century has been the discovery of widespread trophic cascade. Trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years, but the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds, of migratory birds, started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behavior of the rivers. They began to meander less. There was less erosion. The channels narrowed. More pools formed. More riffle sections, all of which were great for wildlife habitat. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
What's that? No, I meant here. Hold on a second. Yep. Hold on. No. Yes, stop. This thing. Hold on. This thing. What's that? Milky Way, yeah. Isn't that cool? We hardly don't ever see it around here, but I saw it the other night, and I was pretty stoked about it. What's that? Yeah, I didn't see it looking like this. The only time I've seen it looking like that was like when I'm like in the Everglades or sometimes out west in the middle of nowhere. But we should be able to see it every night, but why don't we? Light pollution, big time. Yeah. Okay, hey, that's all I got. I like that video. It's kind of soothing. Any question from you, Mags?
No.
All right, great to see you. Email me if you have any issues.
Okay.
Okay, bye.
Bye.